So this is limits. So what is a limit? The limit is what our function is approaching as our x approaches some number. So the limit of f of x as x approaches a is equal to L. That is how that is read. And so what's happening is we want to look and see what we're getting close to from the left and the right. So coming in from the left and from the right, what y value are we approaching as x comes in from the left and the right? And you can see that it's L. And then over here, the same thing. You can see that L is a removable point here. It's got removable discontinuity, but still coming in from the left and coming in from the right, as we're getting arbitrarily close to that a value from the left and the right, what is our function getting arbitrarily close to as well? And you can see it's also L. We don't even have to have the value existing there as well. Still coming in from the left and the right, as x approaches from the left and the right, it's still L. So in all three cases, the limit as x approaches a of f of x is equal to L. So we're not looking for what is the function's value at L. We're not looking for f of a is equal to L. We're looking for the limit. So we don't care what this is. We just want to know what are we getting close to. So here's some problems we're going to look at with Desmos and our graphing calculator, and we can see what's going on with those problems. So what we're going to do is plug this in our calculator and then take a look at it. So if we do alpha y and we plug it in, we get x minus 1 on the top, and then x squared minus 1 on the bottom. So now what we're going to do is look at this graph. And so first thing you want to do is go to your window. So click on window, and we want to get this around this number. So a little bit to the left and a little bit to the right of 1 would be 0.9, and a little bit to the right would be 1.1. So we have 1 in the center of those two numbers. And now if we hit zoom and 0, it will fit our graph within that area. So we're graphing this from, right now in our window, we're going to go from 0.9 to 1.1. So that way our 1 is here, because we just want to see how is it approaching. So at our calculator. And you can see that's our little point right here. We already have a point of discontinuity at 1. If I were to plug 1 in here, we get 1 minus 1 is 0. It's undefined, but we don't care about that. So we hit the trace button, and you want to scroll. So we're going to come in from the left side, and you can see it's approaching some number. And then from the other side, you can see it's approaching some number. So it's just like we did with the limits before. You have 0.49, and the other side you have 0.50. So you can see at 0.4996, nothing, 0.504. So when that hits 1, right, there's nothing. But coming in from the left and the right, you can see that it's 0.5. So we have this situation coming in. So coming in this way, it's 0.496, and then over here it's 0.504. So we're like right in the middle there of 0.5. That's our limit. That's what we're looking for. So in Desmos, it would be the same thing. There's my function, there's my limit of 1, and you can see coming in from the left towards 1, right? It just jumps. You see it jump right there. So a little bit to the right, it's 0.51. A little bit left, it's 0.49. We know it's 0.5. It's a half. So that's what we want to do with each of these. We're going to plug them in our calculator, and we're going to take a look at them. So let's try our next one. Absolute value of x. So again, alpha y for the fraction. And then if you hit math, you can scroll over to number, and you'll see absolute value. And then we put the x in there, put an x on the bottom, and we go back into our window. So on this one, we're looking for 0. So a little bit to the right would be negative 0.9. Sorry, negative 0.1. And the other side would be 0.1. But negative 0.9 would work as well. You can even go from negative 1 to 1. It doesn't really matter. So let's try it that way just to show you that you can be a little bit off. So 0, negative 1, and 1. That's where we'll put our two numbers. So we're going to start our x min at negative 1, our x max at 1, hit zoom 0, and we should see 0 dead center. Just whatever two you pick, make sure you put it dead center. And you can see right here, coming in from the left and the right, they don't approach the same thing. So coming in this way, And this way, right, as we approach 0, we get two little open dots. That doesn't matter. But coming in from the left and the right, it's not the same thing. In fact, what is it? So let's hit trace. And so you can see coming in from the left, it's -1. And then coming in from the right, it's 1. So we're going towards -1 and 1 here. This is a DNE. It does not exist. In order for it to be a limit, it has to approach the same number from the left and the right. Let's look at another one. Sin x over x. Clear this out. Alpha y again. And yeah, we're using fractions because they give us good starting values for these problems. And then we go to our window, and we are going again to 0. So those two numbers that I had, -1 and 1, will work perfectly. So again, sin x over x, -1 to 1. Zoom 0 will give us our picture. I'm going to hit trace. And you can come in from the left, and you can see we're approaching 0.998, so it's 1. Coming in from the right, we're also approaching 1. So from the left and the right, it's 1. So let's draw this little picture. So we go from -1 to 1 with our 0 in the middle. And our graph did this. There's a little open dot here because, again, cannot have that, right? If I plug in 0, I'd get undefined. But coming in from the left and the right, we approach 1. And there's your limit. So that's all you're doing. You're looking to see, coming in from the left and the right, what number are we approaching? And if they're not the same value, it's a DNE. Here's a nice fun one for you to try. So plug it in your calculator and give it a shot and see if you can find out what the limit is. Hit pause now. Okay, so yeah, this was to mess with you. But it's the same idea. If you see it goes in and in and in, we go, oh, well, let's just zoom in some more. So if we take our window and we go -point, throw some zeros in there, and then do the same on the other side. Now we're the same. We hit zoom 0. It looks the same. It's going to continue doing this as you keep getting closer and closer. It just alternates like this over and over and over again. This is a DNE. It's another form of it. So there you have it. Basic internal limits. Thank you.